Here we go with 8.3 standard deviation. So today our objective is that students will be able to find standard deviation. This is numerous times you will see this on the Regents guaranteed. So in our previous example we talked about interquartile, max, min, mode, mean, medial, and all of those sorts. So what we're going to look at today is a more important measurement of dispersal. Remember we said dispersion is the interquartile range when it measures like how spread out the data is. We're going to look at something called standard deviation, which is derived from this formula here. Deviance of some x is equal to the square root of all of this. I'm not going to get into detail to confuse you, but the good thing is that we will be using our calculator. So, what I want to do is go ahead and I want to calculate all of this. So what I need to do is I want to be able to calculate, this is called the deviance. Now before I do anything, I need to know what's the mean. So my x bar, I will take this off. So you're going to write this and then you'll see me take this off. So my x bar is actually going to be 2 plus 4 plus 5 plus 9 all over 4. This becomes 20 over 4, which is 5. So for this question, my mean is going to be 5. Okay? The first thing I want to go calculate on this formula, and I need to make sure I get a line so I can separate these, is how do I get this formula? So I'm going to do piece by piece. I want to work on this piece first. It says x to the ith power, whatever it is, minus the mean square. So the first number in our set is 2 minus 5 square, 4 minus 5 square, 5 minus 5 square, and then we have 9 minus 5 square. What does this give you? This actually gives you 9, 1, 0, 16. So those are the number here. And remember, what does this mean? This little sign right there, it's the sigma sign, which means is the addition. So I want to go ahead now and do my deviant sign, which is equal to square root of 1 over n represents the total number that I have in here. In this case, it's 4. And I want to find the sum of 9 plus 1 plus 0 plus 16. So this actually gives me a quarter of 26. And I'm keeping my square root, which is actually equals to the square root of 26 over 4. My question asked me to the nearest tenth. If I put that in the calculator, I will get approximately 2.5. It comes out to 2.549, but it's rounded to 2.5. Okay, it says calculate the standard deviation of both of the data. So my standard deviation is 2.5. Now let's go ahead and try this again. So my mean, 4 plus 5 plus 5 plus 6 divided by 4. This is actually 6 and 4, 10. 20 divided by 4 is also 5. So my mean is 5. I'm going to go ahead. It's 4 minus 5 square, 5 minus 5 square, 5 minus 5 square, 6 minus 5 square. This gives me 1, 0, 0, oopsie, and 1. Then again, I'm going to write my formula. It becomes the standard deviation is equal to 1 over 4. There are 4 numbers. And then I have 1 plus 0 plus 0 plus 1. And all of this gets the radical sign. Go ahead and simplify that. It ends up being a quarter. And that's 2. Put an extra parentheses here. This works out to be square root of 2 over 4, and to the nearest decimal, it's actually going to be 0.7. That's what my standard deviation is. Okay? Now, Eventually, I'm going to show you how to do this in your calculator without having to do all of this. If that was the case, you would have to be doing all of this, taking the square root and find the standard deviation. But that's why we have calculators, correct? So in all practical application, we will assume that the graphing calculator will be using the graphing calculator to find our standard deviation. This was that biologist question. Remember we talked about that where we find the mean, and this is actually from the previous lesson. Let's get that is lesson 8.2. We use the same question. So the mean in that question was 1.92 pounds. We calculated this already. And I want to find my standard deviation. So now what do? You're going to get your calculator, and I want to go ahead, grab your calculators, and we're going to go to list. Again, we're going to go and enter these in. 4.5, 1.60, 1. Go ahead and enter these with me. Remember, if you don't practice entering these, you won't remember these for the quizzes or for your regions. 1.09, 1.23, and you have to be very careful that you're entering the number as is, meaning the way you see them, 2.28. We don't want to get a different answer from what we're supposed to. This actually 79, 1.48, 1.62, 1.71, and the last one is 1.41. So this is our data. Go to menu, same thing, statistics, stat calculation, which is 1, and I want to do a 1 variable statistics. 1, okay, okay, same exact thing that we just did, okay? So what are we looking for? The question says, use your calculator to sort the data in ascending order, then use your answer from part A. Oh, wait, we're not done actually. Back to part A, sorry. Find the mean, which we did already, and the standard deviation. So we want to find the standard deviation. So standard deviation is that little sign. Now, we have approximately 2 answers. There is this S of X, which is what we use majority of the time, which is a sample population. Or we can use the variance, this is called a variance letter, of standard deviation. This is when you're given the entire population. So for example, in this question, we were given the entire 15 pounds of these trout. So our standard deviation in this case would be 0.64 pounds. I am using this. Where do we go? Point. Here we go. Up, 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 up. Here we are. Wait, how did I get? Oh, sorry. There we go. I had another thing open. So I'm using 0.63, but I'm rounding this. I am using this one because I'm given the entire population. You will see in our next example that we will be using these when we're giving sample population, okay? So part B says use your answer to sort these in ascending order. Then use your answers from part B. Determine what the percent of brown trout weighs that falls within 1 standard deviation of the mean. So when you say 1 standard deviation of the mean, it means number that can fall 1 standard deviation above or 1 standard deviation below. So this is something I want you to think about, which we're going to get into our next lesson. You have this that's known as your bell curve. This is your mean. This is our middle. And then when you say 1 standard deviation, it can be 1 this way or 1 this way. And that's what we're going to talk about in our next lesson. So for this, I'm going to go ahead and say 2 things. My mean, take away my standard deviation, and then I want to know my mean plus my standard deviation. So this becomes, work this out, it becomes 1.28 pounds. Let's just 1.92 take away 0.64. This becomes 1.28 pounds, and this is going to be 1.92 plus 0.64, which actually becomes 2.56 pounds. Now I'm looking for trout that weighs between these. And if you look at it, I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 out of 15. And this question asks you for what percent. So there are 9 out of 15 times 100, which will give you 60% that falls within that one standard deviation. So exercise 3, it says, which of the following data set would have the smallest standard deviation? Do this without using your calculator. Now, on the regions, to be honest, if it's a multiple choice question, we don't care how you do the work. We only care about what's bubbled in. So you will be able to go ahead now in your calculator, right? I'm going to get rid of this. I am going to go back to home, choose list in spreadsheets. So I'm going to choose 3, 5, 9, 13, and 18. Okay, these are my, and this is my standard deviation. These are the numbers. So I want to go ahead now, go to menu, statistics, calculations, and I want to do a one variable, hit OK, and then just OK again. It tells you the standard deviation is 6.06. Now you would want to go ahead and do this for all of them, and again you're going to be using this here because it's the sample. We don't know if that's a full set. You're going to do this for all of them. So this is actually 6.06. You want to see the one that has the smallest standard deviation, and that would give you choice 4. So go ahead and try that. So here, what's the difference between sample versus population? How do I know when I use S of X or I use the sigma of X, the standard deviation sign of X? It says, many times when statistical studies are done, it's not possible to get all the data, which is the population. In this case, a sample must be taken. So if I want to do a survey, sometimes it's so impossible for me to get the entire population. So we just take a sample of it, and that's what we do our calculation based on. So there's a slight difference between how the population of a standard deviation, which is this sign right here, which you need to know, is calculated, and how the sample standard deviation, which is the S of X, is calculated. So it's important to pay attention whether you have the sample or whether you have the entire population. Now let's look at this. A car company is trying to determine the fuel efficiency in miles per gallon of their latest hybrid vehicle. They drive a sample of 50 of these vehicles and determine the fuel efficiency. So like again, it says the sample. There's no way we could have done this survey and get every single latest hybrid vehicle to determine the fuel efficiency. The data set is given in the table below. Using your calculator, determine the mean, and I want to find the standard deviation. These are the two things. Round your answer to the nearest 100. So on my home screen, go back to spreadsheets, and I want to enter this. So I want to enter that table. I'm going to go ahead and label this fuel, and then I want to call this, I don't know, frequency 1, because we had something that was called frequency 1 before. And then we're going to enter this 37, 38, 39, 40, 41, and 42. Then we're going to go back up to 1 and enter the frequency 2, 6, 8, 18, and be careful with the numbers, 8 and 1. So I'm asking for the mean. So I'm going to go back to here, and I'm going to go menu, statistics. This is what we did in the previous lesson, stat calculation. So I'm going to just go back up here, menu, statistic, stat calculation, and I want to do a one variable statistics. Bam. Number of list, okay. What's the list? So I want to change that because we named it. Remember we called it fuel. Good. And then the frequency we called frequency FREQ1. Be careful to choose the correct one. And I want my answer to be in column C. Hit OK. So from this, my mean is 39.48 and my standard deviation is, actually I won't even use this. I'm actually going to be, think about what we just said. We're going to use the sample because this is a sample. It's actually S of X. So my mean we said was, where is my mean? My mean is 39.48. 39.48, and my standard deviation is 1.09. Based on A, how many cars are in a sample that had a fuel more than one standard deviation below? So below, one standard deviation below, just like what we did, is going to be what? It's going to be below, so it's going to be the mean. Take away your standard deviation, so this becomes 39.48, take away 1.09, which will give me what? 38.39 miles per gallon. So 38.3, but the question say how many cars are below 38.39. So here, fuel efficiency is 38.39 is somewhere between here. So we're going to look at 38 because that's of course is below it. And then anything that's below would be this way. So the number of cars is actually going to be 6 plus 2, which is going to be 8 cars. So again, this is one standard deviation below the mean, 38.38, which is somewhere between 38 and 39. 38 is actually less than 38.39, so we can count the 6 cars plus the 2 more that's there, and we got our 8 car. The next one says the government will only allow the company to advertise the fuel efficiency for a vehicle that is at most 2 standard deviation above the mean. Can the company claim this car gets 42 miles per gallon? Explain. So 2 standard deviations, so this will be above the mean. The mean plus 2 standard deviation. This is going to give you 39.48 plus 2 times the standard deviation. This is actually going to give me, let's get some room here, 41.66 miles per gallon. The question say, can the company claims that the car gets 42 miles per gallon? So you're gonna say, can they claim? Of course not. 42 miles per gallon here is greater than the actual calculation, which is 4.66 miles per gallon. So that means the company, this is G, the company cannot claim the car gets 42 miles per gallon. The car actually only gets 41.66. So this company, if they tell you the car is getting 42 miles per gallon, then they're wrong. And this is something that when you go car shopping later on, maybe in next couple years from now, this is something you look into. How many miles per gallon do you get when you buy a car? So until then, scholars, good luck, and I'll see you soon.